Okay, so we are moving on to exponential functions, target 9C, which is going to be writing exponential functions to describe real-world contexts, including growth and decay models. Okay, learning goals. I can identify whether a function models exponential growth or decay. I can write an exponential function for a real-world context. I can write the formula for an exponential function and use the function to answer a real-world based problem. All right, so exponential functions are going to look like this. The only thing that could change possibly is this, and I'll go into that in a second. But for now, just looking at this, we have f of x equals a times the quantity, 1 plus r, raised to the t power. All right, so here's what all this stands for. A is your initial or your beginning amount. So it's similar to the, a sub 1, that you've seen with the explicit function, except now we're just going to call it a. Okay, R is the percent increase or decrease written as a decimal. This is going to get tricky. So like if you have a percent and we say, okay, so we're raising it, there's growth by 3.1%, what that's going to translate to, your R would actually be 0.031. Okay, so make sure that your conversion is correct. So conversion is important. Okay, conversion. So just basically whatever the percent is, move the decimal place, the decimal 2 to the left. All right. And then it's either going to be 1 plus R or 1 minus R. If it's growth, it's going to be 1 plus R. If it's decay, it's going to be 1 minus R. All right. So basically, your end result, if it's bigger than 1, it would be growth. So anything larger than 1 would be growth. Anything less than 1 would be decay. Now, when this could change is if we say something doubles or it triples or whatever. We're not talking about a percent. In that case, like if it was doubles, we would say a times 2 to the t power. If it like tripled, we'd say a to the 3 times, or a times 3 to the t power. So just be aware of that. If it's percent, we're going to do it this way here. All right, and then t is your time period. So however many time periods there are. So you got to be careful, and we'll go through some of these problems and show you why you need to be careful in a second. So exponential growth, that's when there's an increase in value, such as like an investment, an increase in population of a city, increase in value of real estate property, maybe not so much nowadays. Whereas exponential decay is depreciation of assets, meaning like car or money or equipment. Like the minute you buy a car and you drive it off the lot, its value depreciates or it goes down. Population of an animal is decreasing, radioactive decay. So these are all words to look for: depreciation, decrease, and decay. Those all show exponential decay. Okay, so let's look at the first example. We need to write an exponential function that models the following situation. We buy a commemorative coin for $110. Each year the value of the coin increases by 4%. All right, so we've got our formula here. All we need to do is write an exponential function. So we're going to be replacing a and r. That's it. And actually, once we replace r, this is all going to be combined into one thing. So your a is 110. Your r is 0.04. All right, so now we combine those two together. 1 plus 0.04 is just this. So it would be f of x equals 110 times 1.04 to the t power. I'm going to touch on this towards the end once we actually put something in there, because something I've noticed students do in the past, I do not want you to do. All right, second example. Write an exponential function, again, that models the following situation. The population of lions is 15,000 people, and it is doubling every year. So now we're not talking about a percent. So instead of the 1 plus r or 1 minus r, we're just going to say r. What is the factor that it's increasing by? So we have a, which is our starting amount, which is 15,000. And since we're doubling, we're going to be putting a 2 in there. And then again, raised to the t power. Don't forget about that. Third example. We buy an antique table for $525. Okay, so that's our A. That's how much we bought it for. The value of the table increases, so we know it's going to be 1 plus this each year. what is the value of the table in 15 years? So this is our t here. So now we have our a, our r, and our t. So our formula, going by this, f of x equals 525, because that's our starting amount, 1 plus, now it's 10%, so we're just going to move the decimal 2 to the left, which is going to be 0.10 to the t power. So our final formula, our answer would be this. Okay, you could put 15 in here, you could put t in here. Since they're asking about 15, that's what I put in there. Okay, because we actually have something to put in for t. Now, value of the table. Really as simple as putting it in your calculator as long as you do it right. What this part is not, this is not 1.10 times 15. Okay, do not do that. What this is 1.10 to the 15th power, which means it's 1.10 times itself 15 times. Okay, so don't make the mistake of just saying, oh, this is 1.10 times 15. Also, don't make the mistake of doing 525 times this and then raising it to the 15th power. So assuming you put it all in your calculator right, should look like this when you put it in. Your answer would be $2,193.06. Almost always you're going to have to kind of round this to the nearest penny. All right, so just make sure you do that. Next example. You drink a beverage with 120 milligrams of caffeine. The amount of caffeine in your system decreases, so it's going down by 12%. So there's our R. This is going to be 1 minus because it's decreasing after 3 hours. So that's our T, and then here's our A. So again, we set up our formula, f of x equals 120 because that's our A. That's what we're starting with, times 1 minus because we're decreasing. So it's not 1 plus, it's 1 minus 0.12 t. Okay, so we're going to put that as 1 minus 0.12 is 0.88. Notice it's less than 1, so we know it's decreasing, to the third power because it's after 3 hours. Okay, because it's decreasing by 12% each hour. So you need to make sure that this lines up. All right, and then again, you put this in your calculator. It should look like that. You would be left with 81.78 milligrams of caffeine left in your system. Fifth example, the starting salary at Blizzard Entertainment is $127,500 per year. You automatically get a 3% raise each year. Write a formula that models this and determine your salary in 9 years. Okay, so f of x equals 127,500 times 1 plus, because we're getting a raise, 0.03 t. All right, and this is going to be to the 9th power, because it's in 9 years, and this is our yearly increase in salary. And then again, you just put it in your calculator correctly, and you will end up with $166,358.58. So again, biggest thing to be careful of here is do not multiply these two together. This is raised to the power, so you're going to look for on your calculators a button. When you put it in, it would be like 1.03, and then you would hit the button that looks like that, and then you would type in 9. So enter this, hit this button, and then type in 9, and then enter. And that'll give you your answer. Simple as that. As long as you're careful, you should be all right. We will practice with this, and if you have any questions, please do not hesitate to ask.